In this video, I'm going to look at how to solve quadratic equations using the quadratic formula. First of all, when a quadratic equation is in standard form, it will look like this, where A, B, and C are numbers. You need to know this because you need to be able to identify A, B, and C in your quadratic equation. A is always going to be the coefficient of your x squared term or your variable squared, whatever letter that may be. B is going to be the coefficient of your x term, and C is going to be the constant. And you'll need to be able to identify those so that you can plug the correct numbers in to the quadratic formula. So in order to solve for x, the quadratic formula says that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so you're going to take the values for a, b, and c and plug them into this formula to get your answers for x in your quadratic equation. So let's try one. If we have 2x squared minus 3x minus 5 equals 0. First of all, if your quadratic equation is not set up like this, then you will need to do some work on it to get it into standard form. This one is already in standard form. We've got everything over here on the left equal to 0, and that's how we want it. Now we can identify our a, b, and c. A is the coefficient in front of the x squared term, so a is 2, b is negative 3, and c is negative 5. So we're going to take those values and we're going to plug them in to this formula. So the opposite of b, some people say negative b, and b is negative 3, so the opposite of negative 3, that's going to end up being positive 3, but I'm just going to go ahead and write out my work for now. The opposite of negative 3 plus or minus negative 3 squared. You want to make sure if you're plugging in a negative number here that you put it in parentheses, especially if you're using a calculator, because your calculator knows order of operations, and your calculator can tell you that negative 3 squared is negative 9 if you don't put those parentheses around it. That's a lesson for another day, but for now just put that in parentheses. Negative 3 squared minus 4 times a is 2 and c is negative 5 all over 2 times a. Alright, so the opposite of negative 3 is positive 3. Negative 3 squared is positive 9. Now, in my class, we don't use calculators, so the way I have my students think about this is negative 4 times 2 would be negative 8, and then negative 8 times negative 5 is positive 40. So we write plus 40 right there. All over 2 times 2 is 4. Alright, so let's keep simplifying underneath that radical. 9 plus 40 is 49. Alright, so the square root of 49 is 7. So we end up with 3 plus or minus 7 over 4. So we can split that up and work each one out. We have 3 plus 7 over 4. And we have 3 minus 7 over 4. Those are going to be our two answers. 3 plus 7 is 10 over 4, and 10 over 4 reduces to 5 halves. 3 minus 7 is negative 4 over 4. Negative 4 over 4 simplifies to negative 1. So our two answers for this quadratic equation are 5 halves and negative 1. Okay, let's try another one. 2x squared plus 3x equals 7. Well, if you notice on this one, it's not in standard form. We need everything over here on the left side equal to 0, and we've got the 7 over here. So before we get started, we need to move that 7 over here to the left side with everything else by subtracting 7 on both sides of the equal sign. So now we have 2x squared plus 3x minus 7 equals 0. Now we've got it in standard form. Our A is 2, our B is 3, and our C is negative 7. All right, we're going to plug those into the quadratic formula. We can still see our formula right here. We're going to have the opposite of B, so that's going to be negative 3, plus or minus the square root of B squared minus 4 times A is 2 and C is negative 7, all over 2 times A. Okay, now we have negative 3 plus or minus. Let's start simplifying what we've got under the radical. 3 squared is 9. I'm going to call this negative 4 times 2 is negative 8. And then negative 8 times negative 7 is positive 56. All over 4. All right, then 9 plus 56 is 65. Now we would want to take a look at 65 and see if that would simplify it all, the square root of 65. But I don't believe there's a perfect square that goes evenly into 65, so I think that is in simplest form. And so our two answers are negative 3 plus the square root of 65 over 4 and negative 3 minus the square root of 65 over 4. Now some teachers like you to separate this. I'm going to show you. You can also write that as negative 3/4 plus the square root of 65 over 4. And that may come in handy in a few minutes if we need to simplify these. You can split it up like that. So this could be how you write this answer. And this one could be negative 3/4 minus the square root of 65 over 4. So it will just be, you know, what your instructor prefers on that. Let's try a couple more. All right, how about 4a squared equals negative 2a plus 3. Okay, once again, this is not in standard form. We need everything to be on one side equal to 0. And we prefer for the first term to have a positive coefficient. So while it might seem easier to move the 4a squared this way, I want this to stay positive. So I'm actually going to move these two to the left. All right, so that means I'm going to add 2a on both sides, and I'm going to subtract 3 on both sides to get everything over to the left. So I end up with 4a squared plus 2a minus 3 equals 0. And I'm going to show you why we don't want this to be negative is because in our quadratic formula, the bottom of the fraction is 2a. And if a is negative, then we end up with a negative number in the denominator of the fraction. And that just is confusing for some people to simplify. We would prefer the denominator of the fraction to be positive. So we're just going to keep a positive if possible. So our a value is 4. Our b value is 2. And our c value is negative 3. I'm going to write my quadratic formula again right here. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug it in. So we have the opposite of b, so negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 4, times c, which is negative 3, all over 2 times a. All right, so we end up with negative 2 plus or minus 2 squared is 4. Negative 4 times 4 is negative 16. And negative 16 times negative 3 is positive 48. All over 8. Negative 2 plus or minus 4 plus 48 is 52. All over 8. Now the square root of 52 will simplify. I know that 52 is divisible by 4. In fact, 4 goes into 52 13 times. And so the square root of 4 is 2. So the square root of 52 simplifies to 2 square roots of 13. So we end up with negative 2 plus or minus 2 square roots of 13 over 8. And this is a good place, like I showed you before, because this does need simplifying, and it might be easier for some of us to simplify it by splitting it up. So if we put each part over 8, we can simplify each part individually, and we might be less prone to making a mistake. So negative 2/8 reduces to negative 1/4. And then the 2 and the 8 here can simplify, and we get the square root of 13 over 4. So negative 1/4 plus or minus the square root of 13 over 4. Okay, let's try one more. All right, so again, this is not in standard form. We need to distribute this out and move everything to one side. So when I distribute this, I get negative x squared plus 6x equals 11. And let's just say I forgot what I talked about up here about wanting a to be positive. And I moved the 11 over to the left. And I ended up with negative x squared plus 6x minus 11 equals 0. And then I thought, oh no, I don't want a negative a value. And again, I don't want a negative a value because it's going to make this denominator negative, and I'd just rather not have that. So you can always take this quadratic equation and multiply everything in the equation by negative 1. Or divide everything in the equation by negative 1, and that's completely mathematically legal to do that, because you can do anything to an equation as long as you do it to both sides. And so I'm going to just mentally go through and multiply everything by negative 1, which essentially just changes all of the signs. Now 0 doesn't have a sign, so 0 times negative 1 is still 0. All right, and now our a value is positive, and that's going to be better in the long run because we won't end up with a negative on the bottom of a fraction. So now I'm going to plug in my values for a, b, and c. A is 1, b is negative 6, and c is 11. All right, so here we go into the quadratic formula. The opposite of b, so negative 6, which will end up positive 6, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 11, all over 2 times a. Okay, so we end up with positive 6 here, plus or minus, under the radical we have negative 6 squared, which is positive 36. Negative 4 times 1 is negative 4, times 11 is negative 44, all over 2. Well, here we're going to end up with 36 minus 44, which is going to be negative 8 under the square root. All right, so when we have a negative under a square root, we know we need to pull out an I Get rid of the negative. Then we take a look at the square root of 8, and we know it can be simplified, and it ends up simplifying to 2 square roots of 2. I'm just going to move the I to the end. You don't have to do that, but I just like it there. And then, like I did up here, you can separate these so that you can simplify them, if that makes it easier for you. Alright, 6 over 2 is equal to 3. Here the 2's would cancel. You cannot mess with the 2 that's under the radical, but these 2's on the outside, 2 over 2 is 1. So we just end up with 3 plus or minus the square root of 2i. So 3 plus the square root of 2i and 3 minus the square root of 2i are our two answers there.